So I think usually first semester due to the Labor Day, I believe the main lectures and the activity of the semester begins after Labor Day week. So this is already third week of the semester, but we are going to start to discuss about the main part of the operating system. However, last week, due to the Labor Day off and exercise lab for GCP, so we didn't complete the chapter 2. So today, hopefully we finish the chapter 2, then start the process management. Okay, so we talk about a lot what is the operating system and including the computer architecture. Based on that discussion, we can talk about what can the operating system support for the user. So as a service. So these are the services that we can consider when we design the operating system, or when we use the operating system, you may expect such the service. Okay. So think about your operating system in your laptop or the PC and the server. So probably not all of these services are supported, but some of them are in your operating system. The first one, definitely when we log on any operating system, we may expect something interface. So that is a user interface. So how many different, so let's line up the operating system first that you are currently use. So there we go. Okay, so probably many of you use Windows. So unfortunately, the UB only support the IT services support the Windows-based operating system, but Android Windows. So nowadays there's a 10, but some of them are using the previous version. But anyway, so a lot of the users in this room are using the Windows. Any other
that we use?
Yes.
Linux.
Linux. So we have the Linux. In the Linux, there are many different versions of the Linux. What are they? Ubuntu. And Red Hat. Debian. If you are using the Raspberry Pi, so Raspberry is based on the Debian operating system. Okay, actually the 99% are the same kernel, but slightly different based on the CPU and the interface. So Debian. Any others? Linux? CentOS. And SUSE? And many others. Okay, so we will see the very interesting family tree of the operating system later, especially Linux, but there are much more because they are open source. So which means you are feel free to use and revise. And if you rebuild the kernel, so if you do not know what is a kernel, we talked before, but we are going to discuss a lot regarding to the kernel. Mainly, we are touching in this class the kernel and where we can add our algorithm and the processes. So these are the Linux. So let me stop here. Then any other operating system? Macintosh. So it's a Mac OS. I think the current version of the Mac OS is High Sierra. Yeah, I think it's nearby, right? The new version of the Mac OS. But I think that if you are interested in the new version of the Mac OS, that you can actually register for the developer and you can test it. It will be soon. So it's a Mac OS. So what's interesting is any other? iOS. That's a good example of they are mainly the general purpose computer system. Okay? So if you are using PC, nowadays workstation and even the server, they are using this kind of operating system. This guy is slightly different. Oh, by the way, today is the first day I actually moved into the Mac in my life. So I spent all 4 days to migrate everything, and I'm thinking whether I go back to the Windows one. because it's really hard to change the interface. That doesn't mean it's horrible, but I get used the Windows and some software. Also, UV does not support the macOS software, so I need to buy by myself some of them. Anyway, so this guy is a little bit different. It's really close. This one is close. It's a commercial version, but this guy is only for the Mac, the hardware. Okay. Then iOS is different, and iOS is the operating system for it's a mobile device. Mobile device is also computer system. Okay, but it's a mobile portable. So it's from the PDA, portable whatever the device long time ago. But nowadays we are using each of you guys at least the mobile device in your hand. Okay. Plus we have another Android. So they are also the operating system. Okay. And any other operating system that you missed? A lot. But I think that you can also consider the Unix. So because the Unix is the kind of father of the Linux system, because the Unix was not the free software long time ago in the 1970, after the 1970 when the first Unix kernel was released. So people would like to enhance and make their own the kernel. So coming from the Unix, then the Linux. In terms of the interface, they are very, very similar. But this one nowadays is much more popular. But the commercial, mostly the commercial, the software and hardware, the company they have their own the Unix system. Okay, like Alpha and something Fedora and so on. So they have their own the Unix system. In terms of kernel, they are much similar. But they nowadays for us this one is much more. Yeah. But they are not separate. Sometimes they borrow the idea of the other operating system. For example, the iOS and the macOS, very similar. So they actually, the iOS borrowed the many parts of the macOS. We will see some of them. And also macOS coming from Unix system. It's a BSC, Berkeley, the version of the Linux, the Unix system. They borrow the kernel, part of the kernel of this one. So they are not actually the start their own. And also Windows, they look history of the Windows as we discussed is starting from the MS-DOS. Even though they throw away. And also nowadays they adapt the port, the shell, the bash shell, which is the main part of the Unix and the Linux system, as a part of the Windows system also. So, and the Android, so Android is a Java framework, but also is the part of the Linux system and so on. So this is what's going on. So it's not possible to select only one. So just if you have the overview of the operating system, it will be much easier to understand the specific operating system. Any of no matter what operating system you are using, we can think about the several core service of that. So first one is the user interface. For example, the Windows, definitely it has a desktop. When you log in, you can see the desktop, which is very, very popular. So because of that, it's very hard to change your operating system to the other. So it's purely the graphical user interface. However, for example, Unix and the Linux, they are command line interface mainly. Nowadays, they provide both of them, like a Windows 10, but like unlike the CMD, it's not the interface. It's just it is interface, but it's not the real part of the kernel, okay, as an application. We will see why it's different. But nowadays, it has the shell, the program, like the bash shell, as the interface. That was from the Unix and the Linux system. Similarly, Unix and Linux system has been developed based on the command line interface, like the prompt. But the people already got used to graphical user interface, like the Windows, the desktop, or the Aqua in the macOS. So they have their own desktop graphical user interface, like the KDE. I'm very weak the acronym KDE, or the GNOME and the genome, or the many other such a graphical user interface desktop right here. And so that is a user interface. We will see some part of that. And also, in your first project, you are going to implement the the command line interface, the shell program, which is I think the most familiar you guys, but not much know about such a command line interface. So after finishing the chapter 3, I will explain the more details about the project later. Okay, then any of the operating system, this one. So as we discussed very briefly about how the operating system works, they are first when we turn on the computer. Why don't you remind what's going on when you turn on the computer? What happens when you're in the computer system, mobile system, or whatever? Then eventually they will start the first process, which is the kernel, the process, or init process. Whatever the name is the first process will be started. Okay? First process will be started means what? We copy the kernel. What is a kernel? It's an operating system. It's the macro view, narrow view of the operating system. If you remind the definition of operating system, broad view, everything. Okay? And macro view, narrow view is only kernel. Okay? So kernel is the most important, the process program. You need to code and compile. It's sometimes called the system generation or kernel rebuild. Unlike the compiler. Okay? It's the same thing. It's a compiler. You need to code. Sometimes C program, C++, mostly assembly language in general purpose, the operating system kernel. But nowadays it's a more higher and higher level language like the iOS, Android, if you know the Object-C or the Java, so you can actually rebuild, compile your operating system kernel. That is the first program, but how can we start such a kernel? We need to copy the firmware. Know where is the kernel that program will be forced. You force that program copy to somewhere in your memory. Then it will be program. Okay? It will be process. So sometimes it's ID number, process ID number 1 or 0, depending on the operating system. Then after that, our purpose of using operating system is what? Hardware. Right? We want to use the hardware. Okay? Through the software, through the program. Right? So then, how can we do that? Only through the process. As I mentioned in the first class, the main part of the operating system is this guy, the process data structure. Process is everything that when we are using the operating system or computer system. So this one, any of them will create the process. Okay? So how can operating system create the processes? This one, process, create the process. And this, like the parent and children process. And this I will create another process, child process. So for example, when I log in to any of the computer, then this will be the terminal process, last process. In other words, interface process or shell program. Or in terms of Windows, it's a desktop. This desktop was created by parent process, eventually kernel. This is called the process, the tree. Then the most of operating system, general purpose, not embedded. Embedded is simplified. But general purpose operating system, they use such a process, the structure that is the program execution. So operating system should be able to design data structure of each process and how to create the process, because we have a lot of processes. So what are you doing when your computer is slow? So you check the test manager. Or if you are using Linux system, the something command, like a PS command. If you are not familiar with the Unix or Linux command, so it's a good time to get used. We will learn throughout the semester with the help of the GA, but it's worthwhile. So you can check the process. Whether what did I show you the top command? So sometimes you can check you can use the monitoring the program, how your operating system is running and so on. Then you can check which process, how many processes, so many processes. If you are using Windows Test Manager, then you can see a lot of processes. Then you should manage. Okay, you have very limited resources. So somebody said the operating system is kind of fighting with the limited resource. In other words, if we have unlimited resource, unlimited CPU, we can put as many processors as possible, CPU as possible. We can increase unlimited the memory. We don't have to be serious about the operating system. Just give any resource. Since we have very limited resource in our computer device, so we need to manage. That is the definition of the operating system. Resource, allocation, and coordinate. So we need to manage such processes that will be the main service of the program execution. Also, in your first project, how can we create such a user interface command line? Using process management. You are going to create the process and execute. That is the process. So that I really like that the first project in my operating system class. Then students will learn a lot of things. Okay? So then, plus in addition to such a main services, we have the I/O operation. If you remember the three main parts of the operating system process, memory, and I/O. All the device, so we can regard all the devices as the I/O, the devices. CPU, memory, the hard disk drive, SSD, file system, mouse, and the monitor. It's I/O. So we need to manage the I/O operation in our operating system, plus several others like the file system manipulation, because our data will be stored at the file system. What is the file system? Data structure. For what? Many? Number of files. So any information, any data in our computer system will be stored at, or sometimes regarded as file. For example, if I connect a new device, how can the operating system recognize it? If you did some microcontroller, the class or something such an engineering class, so you can recognize the new device through the Arduino or the Raspberry Pi. Then you can see the /dv/ something file. It's not real file, okay? But using the file USB 0 is the USB device, or the AF or something like the Bluetooth. So you can recognize any I/O device as a file, okay? So file, how many files? Really, the many files. So to manage such a number, if you check the number of files on your any operating system, it can be easily 200,000, 300,000 the file. Okay, so we should manage such a number of files using another data structure that is called the file system. And also nowadays, there are two types of communication. One is computer to computer, device to device, like through the network. Okay, it's the internet. So internet, the communication. So you probably learn in your DCC class or any other network class. So we need the protocol and the OSI 7 layer and so on. So it's a communication between or among the computer and the server. Also, we are going to focus on the communication within the computer system. So it's an inter-communication process. Intranet. It's not. Anyway, so there are processes inside, they should communicate. So this is called the communication process, IPC, inter-process communication. So IPC. So because we have a number of jobs, number of processes, they should communicate each other. So to do that, the operating system provides the ways to communicate between or among the process. That is called IPC. So this one is supported by the operating system also. Sometimes we can use memory. Sometimes we can use even the TCP/IP communication, the protocol used in the internet, the network. Okay, and error detection and the resource allocation, accounting, protection, security. So these are the core service of the operating system. Depending on the main purpose, specific purpose of operating system, some of the service can be ignored, but the most of service will be supported, and plus the additional the services. So we are going to focus on in this class mostly the first the part like the user interface program, I/O, file system, communication, resource allocation, and so on. If we have time, we will cover the protection and we will deal with the protection and security a little bit, and as a part of the file system. And error detection, 1 or 2 pages, but the other we will cover. Okay, first part is the command line interface. And please pay attention to the command line interface, not like the CMD. And we are going to focus on such a desktop or the shell. We will realize that we will understand that later. Once we are going to see the process group. What is the difference between the CMD and the shell? So basically, shell can create another process. CMD is not. CMD is just pointing. Then the desktop will create the process. So shell is the terminal process and or leaf process or in the process tree. Okay, that will be the interface point to the user. So users are able to do something. Do something means create the process or execute another program through the shell. Then if I ask the shell to create the PowerPoint, then the shell is in charge of creating child process as a PowerPoint. So that is a shell program. So each, especially the macOS, the Linux, Unix, the Windows nowadays, yes, there is a bash shell is part of. So most of such operating system support the shell, the program-based, the interface. This is the command line interface. How many different shell? Really many. So you can see I learned the shell from the K shell, corn shell. So 20-something years ago. But nowadays, most popular is the Linux use a lot, bash, EASH, the bash shell. Okay. Then right now the Unix also support a lot the bash shell, and this file Windows also bash shell, and macOS also bash shell. For example, I'm not very familiar with the macOS interface, so I'm trying. Okay, so not sure whether you can see. So you can see whenever you are using command line interface, so there are a lot of configuration for environment variable. Okay, Windows is the same thing, the Unix, Linux is the same thing. Mostly they are stored at the $. The $ means it's the value of the shell. So I'd like to echo, I'd like to see what kind of shell I'm using, echo $ shell. So you can see the bash shell is currently being used in this, the Mac OS also. And Unix, if you are using Unix, you can do the same command, but they are different, but sometimes not much different. So if you know one of them, then the other is not very complicated. one more thing is the shell is not just interface command only. It can be programmed. So because of that, it's called the shell programming. So for example, I'm doing this one. So then the if. Think about the macro program. What is a macro program? It can record what you are doing. And click. Then if this one, and you can do this. So you can do the macro programming in the Windows, and you can do the macro programming in the, for example, Microsoft Excel, and so on. So very similarly, you can do the programming using the shell. So shell program support if then else, conditional statement, variable, and some even the function or object programming are supported. So if you buy the book for I'd like to learn the bash shell, it's this much big. It's not very difficult the program, but it's worthwhile, especially if you are interested in the management, like administrator, network administrator, the operating system administrator, database administrator. So you should be a very powerful user of such a shell programming. So if you want to see some of the example of such a shell programming, one of the very, let me see, the bash. No, this is not. No, there's no. Okay, so probably it's a maybe different interface to run the profile. Okay, profile is the first program that will be executed when you log on. That profile, I will show you that example of profile using the virtual machine. Okay, probably the bash shell on the Mac OS that use different location of the profile. Okay, then you can see some of the example of the the shell programming. So I strongly suggest you guys learn such a shell programming. Also, the GitHub will introduce how to do the shell programming and as a part of exercise like later. Okay, so that is the shell programming. Okay, and this is an example of the shell that I show you on the Mac OS. Okay, you can do the very similar command as what you are going to learn in any other shell. Okay, so it's not much different. Okay, then what about the graphical user interface? GUI, like the Windows desktop. Also, nowadays the Unix and the Linux they support their own desktop KD or the genome, and also macOS has a very well known the Aqua, the interface that I show you just before. So these are the graphical user interface. So okay, I'm not going to explain more. I'm not going to explain the details of this, but this is the history of the graphical user interface. This is early GUI. Okay, you can see the mouse point here. Okay, it's a zero system. Surprisingly, we are using the very similar interface right now, mouse, and this one is keyboard, and we can control the mouse and the click and so on. That is early GUI, but still used. I'm not sure whether this is really the human-friendly interface, because this is the first user interface for the GUI, but not sure whether also, for example, the touch screen and the swipe, whether that is really human-friendly. So one of the very important research area of computer science is HCI, human-computer interaction. Okay, so they are thinking about touchless swipe. It's already done. So using the camera or the motion detector, so because sometimes you can feel some pain with the tip of finger. Why? The touch screen, actually, when you touch the screen, there are a lot of grid size sensor. so there might be electric. So some are very sensitive person can feel the pain on the tip of that, including me. So sometimes I'm using the other finger, but it's not very correct. And also as you are getting old, it will be harder and harder to precisely control. So why not the touchless? So think about such a the user interface that are very close to the human being. So this HCI is one of the interesting research area. I have used this kind of slide, the file system management interface. So this is actually the GUI Photoshop, all the files in here, and this is the destination. We can copy or change it or do something as a Xerox slide. Collateral. And the 1980s, the user interface. You probably never seen the Windows 1, I didn't. And then you can see the very similar Windows version 2. It's very similar as the version 3, which is the popular version of the Windows. And the OS2 is IBM, the operating system for personal computer. So actually the OS2 and the Windows, they fight early 90 and to the year 2000. Then finally the Windows was the winner. That doesn't mean the Windows is better than the OS2, no, absolutely not. OS2 is in terms of architecture and theory is much better. But due to one of the reasons is the marketing, the Windows was the winner. Then surprisingly, the IBM is a big company in the computer and the computer engineering and the hardware. Sometimes they quickly change their main direction. Like the year 2000, around the year 2000, IBM changed all the service on demand. What is on demand service? Instead of purchasing everything as a package or the turnkey.
It's like, you're saying they like pre-built based on an order, then they fulfill it.
Yeah, or the module by module. So the customer demand this and this service, then the make. Or even I'd like to pay, I'm using based on the usage. Okay? So I'd like to pay, I don't want to buy the entire database system because I'm using the little bit. So can you serve for this one? Then I'm going to pay for this. It's an on-demand service. So everything was changed on demand. Recently I've been changing into the data analytics. They give up all hardware on this service. Really, Lenovo is no longer the IBM. It's China. It's a Chinese company. So something like that. No, IBM chip, you will not see any the CPU from IBM. So really, sometimes it's called a dinosaur in the computer industry, but they quickly change. So too fast to give up the OS2. Still used for a specific purpose, but not much. But I have used a year. It was good, very similar. You can see the K desktop environment is following the Windows style desktop. So it's the Linux has such things. Then finally in 1990, the GUI is started from here. The Windows 95, some of you guys have used. And the Aqua macOS is still the same. What is the name of its style? Yeah. So that is here, then there's a very similar style as the current Aqua. Still it's called Aqua, the desktop graphical user interface. And Windows has been changed, but they cannot throw away the rectangular style window, the WULA. So that is this, and this is current one. And due to the mobile device, so we had a different, because why? This one and the previous one is a different interface. Devices that has a very limited input and output. Okay? Only we cannot use, if we use connector, some of them use the tablet as like the surface. It's one of the I
Hate.
because of the limit, it's not the tablet, it's not the PC. If they can support both of them, that's what I expected, but none of them. So that connect everything, then this is no longer the portable. Okay, so it has only touch or the voice like that, so very limited. So they have the different interface to support the limited the hardware. Okay, and another thing is another limitation, huge limitation of the portable device. Memory, then they are related to energy, the battery power. So they have the very limited battery power. Okay, so even they should change the kernel to save the power. Okay, so that is the reason they do not allow the background process. Instead, is just nowadays most of the tablet they support the multitasking, like the device that consume a lot of power. Because who is the most consumer of the power in the computing devices? CPU actually the first one. CPU. So screen you can reduce the brightness and something like that, but the CPU actually consume the most of the power. Okay. To reduce that, they limit the processing. But nowadays they can support due to the increase the power of the battery. But still battery, the power is not increased like this. They cannot follow the curve of the CPU. So if you have any idea of such a battery, you will be super rich. So that is the reason a lot of companies invest a lot of money to make such a power. We will see about that. Then plus, they have their interface and the process manual. Then the next thing is some of the users would like to create their own program that is sometimes we call application program. Okay. The other, so any program shipped with your kernel operating system are system program. Okay. So system program is okay. The developer of the operating system already made everything, so we can use. But I had especially the computer science student in our major, so we try to develop our own. So I have a new idea. I try to use this operating system and so on. How? Do I need to understand all the input and output specification? The pin 1 is the data in, pin 2 is the data 2, and check. It will be forever. Okay, you cannot understand everything of such a hardware specification. Instead, the operating system provides the number of function, which is called the system call, system API to use the hardware resource. Then we can simplify the program. Also, if you remember, the operating system has the two modes, dual mode, user mode and kernel mode. So when you read the data from the hard disk drive, if you have all the permission to access the hardware, you are not the only one, and another user directly access the hardware, it will be messed up, right? So kernel is in charge of to process such a hardware level, the programming, low level programming, which is the system call, system library. So if I want to do something system programming, then you can just check the number of API. For example, Windows has the the API, and Linux has the POSIX. POSIX is a kind of a standard. POSIX API. Sometimes Java virtual machine, Java API is called system call. For example, the Android is based on the Java framework, so we can consider. Somebody consider the Java as because it's a virtual machine. Do you know how the Java application is running? When you start any Java application, it will be inside Java virtual machine. What is a Java virtual machine? It's a memory area. You cannot use out of, so for example, so any processor will be created somewhere in your memory. Okay, especially Java. Java allocated. You need to have a Java real time. Runtime environment. At least you should have the JRE. That will create somewhere in your memory as a Java virtual machine. So whenever you run the Java application, it will be inside. Then Java virtual machine will be in charge of like what? Operating system. So that is the reason somebody consider, not all, I don't think Java API is really the system API, because anyway, it's nowadays Java, the virtual machine technology is another part of the operating system. So anyway, we can consider. So these are the system called system library, system API. It's the same meaning. Okay? Who provided operating system? The manufacturer provided such a thing. Then, for example, these are the example of the Linux, the system library. How many of them in this case? 190. So you can see some of the simple. So what if I'd like to get the process ID of the from the process? Get PID is the function system library. In here, they are usually C or C++. Okay. Sometimes may be different, like the Java API, but mostly C or C++. So inside the system, inside your C or C++ program, you can just use get PID, system library. Then, once this one is executed, who is in charge of to run this function? Kernel, not you. So at that time, it will be, if you call the system library, then the kernel mode, your system mode is changed to the kernel mode, and the kernel is in charge of that to get the process ID. Because of that, as I showed you the last time, the CPU is usage of CPU divided to user, sys, idle, and so on. Okay. So how can I use this? Do I need to remember? No, you don't have to remember. Whenever you need, you can just check the reference of your operating system. If you are doing the Windows programming, do you remember, memorize everything? No, you don't have to. Just if you are able to search, then pretty much it's okay. Then check the argument. Also, if you are using the command line interface, is there any need to increase the font size of this? Anyone? Anyone? Control Windows is a Control ++, right? Like that. Right. You can use the man. Man command is a manual command you will learn in your exercise lab, like the -k is a keyword, like the get PI. So you can see, for example, the get PID is there is a different level. One is the application level, two is the library level, and so on. So it's get the parent or calling process identification number. So you can use the get PID. How do I use how do man get PI? Then you can see the details of that. Always you can use the man page while you are using command line. If you do not know how to do that, always Googling. Okay, Googling shows that this one, and sometimes much easier the way. But I like this way to check. Okay. And this is just an example of the one of the Linux system, the core. The interface, depending on your operating system, it may be different. Some of it's usually less than 200. Okay, then we can make any kind of the system program. Also, one of the if you are searching job, so probably you will check a lot of job description, and you may see the +3 years of the system programming. System programming, application programming, actually they are not much different. First, you should know how to use, how to compile the program language and so on. But when they are asking the system programming, whether you are able to use such a system library. Also plus a little bit hardware knowledge. Because first, we developed a new device and we'd like to use a USB. At least you should know how the USB use how many lines and pin and which one is data in, data out, which one is ground, which one is plus, and so on. Okay? Then you can do the system programming using the system library. Okay? This is an example of the copy, the file. So have you ever used the cp command or the copy in the command line? It's a copy the file. Okay? Control C, Control V. So actually this is how many lines? 1, 2, 3, 4, 5, 6, 7 lines of code to make the copy command. Okay? How can we do that? Using the system library. Open, you don't have to implement. It's the system, operating system provide. Open, and the argument is the argument. So this is the source. And so first you need to check the file system setup, whether the file is existing or not, and you have permission at first step. This is also system library. And finally open with some argument like the write permission or read permission and so on, and send the file from source to destination, and after you done the close, and then that's it. That's the system programming to implement a copy. Okay. Then you can compile this one, put somewhere on your path. Path means there is a number of a directory where your process can find your binary. Okay, we will learn a little bit more details during the exercise lab. So you can, if you put the compiled one to the somewhere on the execution path, then that's done. So that's how it works, the system program. What about the Windows? Windows is the same thing basically. Windows provides the Windows API. Windows API is a create a file. Name are different, but it's basically system library API. So read the file and so on, like this. Okay. So nowadays, so if you search the job, you can find such a system, the programming experience. That means whether you are able to use the system library or not. In terms of dual mode, you can understand the system core interface with the dual mode, usual mode, and kernel mode. Any source code, any the command that are not using like the conditional statement, while loop, for loop, variable. Such a thing will be done in the usual mode. Then once like the open, the file open will ask to the kernel. Kernel is in charge of to execute the open, that return only output, whether success or the value and so on. Then this is another reason to use the dual mode. Otherwise, you need to give all the permission to the user. It will be security hole also. Not only synchronization issue or the method, but security, the hole. It will be security. Okay. However, whenever we use such a different layer, different mode, they should be able to communicate. That's the big problem always. So how can we communicate? At the time we can use a parameter passing. So any data to the argument or output, you can use the memory area. Then put the output and input is called the parameter passing. We will see a little bit more during the communication of the processes. What types of system core? So this can be summarized as this one. This is the same as what we have discussed in the service of the operating system. Okay? So like the process, and then file, device, and maintenance, communication, and protection, security. So we can divide such a number of system core as the service of the operating system. You can understand each of them. So these are the well-known, very popular, the system library. That probably even the application program uses some of them, like the process to create. So in your first project, we are going to create your own shell programming. What is the main job of the shell programming? It's an interface for what? System programming. Using system programming, you are able to create process. That's the most important job. Okay, that's everything of actual operating system. How can we create the process? Do I need to know memory address or how to? It will be really complicated. So that is a fork and exec.
But would you say that's like there's like system level, and then there's something above that, and then there's like basic.
Yeah.
Because it's like
it's not clear actually. Okay, it's not clear. Sometimes you can use the system library in your application program also. So it's not really clear. For example, database. Database, what kind of database do you know? Oracle, for example. Oracle uses a lot of the system library. Even they create their own system library to access what? The memory or process information. Then can we say that is a system library? It's an application anyway, but it's including system. It's not clear. You cannot divide it into this is application program, this is a system program. You can use some of them in your application program also. Okay?
Because could it still be possible to do something in Java that you could still do in Shell?
That is if you are using different program languages. So for example, Java, how can we use the C or C++ library? Then the Java virtual machine has the interface kind of wrapper to access. So you don't have to worry about the behind, outside of Java virtual machine. JRE itself has such an interface system program. But sometimes you can use the directly in your application to the C or C++ library using through the wrapper. Nowadays, such a wrapper program is very popular, so you can directly code. So it is possible. But in case of Java runtime environment, JRE virtual machine is in charge of such a other system library to the inside the Java virtual machine and Java API. Okay, so these are the popular. In case of the project, you should be able to use the fork. This one. You probably heard about this most popular system library, fork and exec. When I worked for my first job, excluding me, he didn't ask me such a question, but whenever we hire or interview the new employee, he asked my boss, what is the difference between fork and exec? It's a very popular still. Whenever we are using computer research to do the operating system, a lot of fork and a lot of exec happen. So we will learn what are the different, what are they, what is the difference. And the Windows has the same thing, the create process. You are able to create the new process. And the exit file system, probably you use a lot of this. Nowadays application program need to able to access the file system, create the file, and delete the file, and so on, and device information, such a thing, and the communication also. So communication, we will talk about is called not the intra between the computer, but inside the computer. The inter-process communication using pipe or the memory, the shared memory, and so on, and the security. These are just limited, the selected number of the system called system library. Okay, before we start the main part, the process management, we will quickly see the history and the basic operating systems one. So everybody knows the MS-DOS. DOS is the operating system. D is the disk, I think the disk operating system. So it's those. It starts from the Windows that actually Bill Gates used the MS-DOS. On top of that, including the MS-DOS, he built his own, the Windows kernel. So MS-DOS, main difference between the MS-DOS and the other operating system is MS-DOS support only single process, single job. Okay, you cannot run the multitasking, you cannot execute the multiple process, only operating system, then one process. Okay, that is the main problem when Windows has the both MS-DOS and the Windows Phone. Okay, so it's sometimes it's kind of the two owner of the business and two president of the country, two chairman of anything, like the two operating system. Because even though MS-DOS is able to create one process, this is the operating system. It has its own kernel. But in addition to that, there is another kernel that is a Windows. Long time ago. Windows 3.1, Windows 95 to the 95. Two operating systems are running the same time. So because of this reason. Okay, but nowadays, most of the operating systems support multitasking. That means we are able to create the multiple process. By the way, whenever I use like this rectangular, okay, or this rectangular, this is most of the time memory. Okay, it's a memory space. Then the address 000 to the FFF, the higher address, like this one. So it is true, most of the operating system use the lower address for their own kernel. Okay, and whenever this kernel create the process, this one, it's a multiple process will be created. So you will practice creating process in the exercise lab as well as in your project later. Okay, then if we are able to use this kind of the API, we generally say this is a system programming, but it's not very clear to divide. This is a system programming, this is an application programming. So nowadays it's a mixture. Okay. Okay, so I think that this. And finally, if I'd like to build our own operating system. It is true, it is not easy to develop the new, brand new operating system. Most of the nowadays operating, including macOS. macOS is not the brand new one at the time. It's based on the BSD, the kernel on the Linux system. Okay, but anyway, so I'd like to develop the new operating system. While we build the operating, how can I? You should be able to use the program language. What kind of program language? Eventually, a little bit assembly language, but not easy as you have learned in the microprocessor class or the other. So nowadays, most of the kernel can be built by the C or C++, sometimes Java. But the C and C++ are the most popular one. That is the reason operating system core level interface, the system library, is based on the C or C++, but the Windows has support also the C and the C++, and so on. Okay. Why implement every time the kernel then test with the real? So you can find the emulation. So you don't have to actually test the real hardware, the real kernel. Instead, you can use the emulator if you are using if you want to develop the operating system. Okay. So we already showed some of the example of them. We will quickly see. Yeah? This is MS-DOS. I'm not going to. Anyone who learned the MS-DOS? Probably not. When I learned the computer first time, we learned the MS-DOS. Then how to copy. COPY, source and destination. That's what I learned. Okay. Then that is the simple operating system MS-DOS, but the Unix. From the Unix is general purpose, which means it's creating multiple process, multitasking. Okay. So this is a very, very simple history of the Unix. The history of Unix, Unix family tree. So start from the, we are saying 1970. So what about the time on your PC or computer? Even though out of battery, do you lose the time and date? No, why not? Why? It has a battery inside. Without power, definitely you lose. But inside on your device, there's a small, tiny, usually motherboard. It's a battery. What if even the battery on the motherboard is gone and replace battery?
Does it calculate when it was turned off or something?
What will be the time? It will be 1970, January 1st, 0000. Because in the, according to the Unix history, the first version of the Unix start 1970. So if you replace your battery, you may see some of the virtual machine. When you see the virtual machine time, it will be set as the 1970 because of this reason. You may not see before that. Okay, so even though it's a prototype and the 1970 it start it's a 5th, 6th, 7th edition. Then basically two branch of the Unix system. One is the BSD, it's a Berkeley System Development or something like that. It's a Service R project. It's the SVR. So for example, the Sunways, old version of the Sunways is based on this one, and the Mac OS is going to here, and many of the commercial, the Unix system is from the SBR. Okay. I'd like to see every semester. This one, anyone can help? Going back. Going back. So this is a detailed version of this one. What's the year?
69.
It's starting from the 69. So if you click the one of the link, you will see the latest version. I give up to add a new one. So after it's 2016. So it's a keep modifying, and rebuild and the new version. You can see the details. I'm not going to have the test for this. Just leave it. Just leave it. So this is the real history. So still right now, a lot of people and the company, they are rebuilding their own kernel. Not only the Windows or the Apple, they are hiring the OS experts. No. So even small companies, they should know the operating system and the embedded operating system. A lot of them. If you are interested of this one, you can check the one of the, I think the first one will be, last year I checked it's updated, but not sure that this year. Okay. So there are different ways of developing the Unix system. First one is the layered approach. Layered approach, as you can imagine from the name. So we have the different layers of. If we develop all the things together, then one program, one kernel, it will be good to test. No, it will be good. It's not very good, but anyway, you can put everything. But if something happens, it will be very hard to debug and modify and the thing. Most of the modern operating system has different layers. Like the first layer is the hardware. Then I had a new idea of swap. So swap is another layer. And this one, most outside the layer is user interface. So if I have a new type of interface, you can only change this one. You don't have to compile, rebuild inside the layer. Okay? So it's a layered by layer, layered by layer. And inside is a hardware layer, outside is a interface layer. Okay? It's a layered approach. Benefit? It's good for the maintenance, okay, and developing purpose. It's good. Problem? You need to understand everything. You don't have to understand everything. You just know the next inside the layer. but you should be able to communicate. Okay? So to use the hardware, you need to next layer, next layer, next layer. So it's a communication overhead. So if you are able to, like the system library is one of them. If I can directly access the hardware, you can code it. Okay? Then run in your application program. But mostly recommend using another layer, that is the system library layer. So you should know interface, like what is the input, what is the output code. It's very important whenever you are doing the system, the programming. You should check the output code. 0 is usually okay. The 1 has the meaning, -1 has the meaning, and for example, when you create the process, the output is a positive number, like the 10. 10 is the what? Your child process I. And the 0 means something. Minus is something problem. Okay? So that is because of this kind of layered design approach. Okay? And also nowadays, which one is better, you think? The huge size, everything inside the kernel, or small size of the kernel? Small. Definitely. Then we can add either or add another layer, something. That is called the microkernel system structure. So for example, the Mac OS is called the Darwin. So how can I check? So if you, first, whatever the command line interface you use, I'd like to know, I do not know what is this. Then how can I check the kernel, type of kernel and the version of the kernel? It's uname is the command. So mostly -a option. So uname. You can see it's a Darwin. It's the kernel name. So at Mac OS use the Darwin. Then the version is the 17.7. Darwin kernel version. I think that this is a High Sierra version. Then the time and something other information, like this is x86 and the 64-bit, and XNU is the building, the environment, and it's 2008. This is current time. June. Oh no, it's last rebuild time. So June 21. You can get such a kernel information. Yes.
So if you were to update them, when the future one comes out,
yeah,
whatever they call it, will it have an update?
Oh yes, that is the updated kernel. Okay. So if you have the next version, I forgot the code name of the next version, but so I just upgrade from the Sierra to the High Sierra. Then this information was changing. Okay, so code name is nothing but just code name. If you want the details of that version, you can check their kernel version. It's actually started from the Darwin. Darwin is the microkernel, so you can add. So we can see the more details of that. So like this one. So not this one. Where is that? Yes. So this is a Mac OS X structure. It's the microkernel. So we have this is a microkernel. So they actually started by adapting the BSD, as the chip. So it's the Mac OS use the BSD, the kernel as a part of their microkernel, and they add application level the service like the Java, Cocoa, the Object-C, and the QuickTime for the multimedia. Then the final the interface. And behind the Mahu, there's a different layer, so the IO kit and so on. This is the benefit of the microkernel. Sometimes if they just slightly revise application layer, they do not say this is a new version of the operating system. If a major change on such a thing, then they will the rename as a component, because it's entirely, they cannot support the comparability of the application. Some of them. Okay, most they try, but some of them will not be. Okay, sometimes we can combine some other. This is the modular approach. Unlike the layer. Layer is cover the kernel most inside, and another one, and communicate through the layer. The modular approach is we have a core kernel that plug-in style. Okay, directly communicate. So Solaris use this one, then because they directly set each module by module. So one time, so even though there might be executable format, compiler is one of the modules. So when we purchase the Solaris operating system, then I cannot compile. So I ask the device, this is not there, then you need to buy. It's like that. So they can add such a modular by modular approach, directly connect to the plugin, to the kernel. So nowadays, we can use both of them hybrid system, like not only layered and from the microkernel, and you can add the different layer or plugin and so on. And nowadays, for the mobile device, we have iOS. So iOS is very similar as this macOS, the microkernel. It's called Mahu. I think the name is Mahu. Mahu is the macOS, the kernel name. So very similar as this one, but different layer. So core operating system and service. They focus on a lot for the media service. Why? Main reason to use the iPhone or the Android phone is to take a photo and watch the movie and the YouTube and a lot of the computer research used for the media, the service. So they focus on a lot. Then they are using the Object-C. So if you want to do what is that? Programming, Android app programming. Okay, so you should learn different one. Android is based on Java, but this one maybe changed because of the issue between the Oracle and the Google. Oracle actually owned Java, so they had a lawsuit, a huge one. I cannot remember the result, but because of the maybe changed, but it's currently based on Java. But iOS has their own Object-C API. So you should know this one. And plus, one more thing is the power. So you need to consider the power management in the mobile device operating system. So for example, one of the thing is at the same time you can limit the number of processes, active processes. It is true, CPU can process only one thread, but we can pretend executing multiple by switching. It's a context switch and scheduling. But that doesn't mean that we can save the resource of the other inactive process. No, they are consuming the processes. So either resources. So old version of the Android and iOS limit the current one process only. But nowadays, background process is available due to the better the capacity of the memory, not memory, the battery power. Each operating system provides the debugging and the monitoring. Okay, I'm going to skip this part. How can I reveal? Each operating system provides different ways. This is one of them. So there is a program, like this system is available Debian operating system. So system is the program for user to reveal the conveniently. Okay. So if I have the new CPU scheduling algorithm, then you can add the CPU scheduling algorithm to the kernel. How can I add? Using the system. Or depending on the operating system, it has different one. Then you can make your own version. Then if that is the verified use for public, you can add to the history, family tree of the Unix. Okay. Okay. What time? 1 minute. Then the chapter 3, so 3 main parts as we have seen, as we discussed a lot the last few weeks. So process management and memory and the I/O. Okay, so first part is the process management, and the next class. So we should be able to create the process. How to create? Using system library. Okay, then we will see really what happened when we are using such a system library, such as a fork and exec or create process on the Windows API. Then this will be very important to do the first project. Okay? Okay, any questions? Next class, we are not going to have the exercise lab. Instead, continue to the lecture, chapter 3. Then next week, Wednesday, we will do the both first exercise lab and the second exercise lab together in the classroom. To do that, you must create your virtual machine on GCP. Okay? If you do not create yet, why don't you contact the GA or me to get the coupon code? Please practice with the command that I introduced here, and especially editor, VI editor. Okay, it's good for you. Okay, thank you, and we will see you on Wednesday.